It is April 18th, 2018, just after 6:37 p.m. Eastern Daylight Time, and you are looking at a live view of the Falcon 9 rocket with NASA's Tess spacecraft on top, awaiting its 6:51 p.m. local time launch. Good afternoon from SpaceX headquarters here in Hawthorne, California. My name is Lauren Lyons, and I'm engineer in our Flight Reliability Department. And I'll be your host for today's webcast. Today we are launching NASA's Transiting Exoplanet Survey Satellite, or TESS for short. After Falcon 9 drops it off in a high Earth orbit, it'll be on its way to go hunt for potentially habitable planets outside of our solar system. And SpaceX is super excited to be playing a role in such a cool mission today. Throughout the webcast, we're going to tell you more about TESS, how Falcon 9 will get it to orbit, and bring you video of our attempt to land the first stage on the East Coast drone ship, of course, I Still Love You. Now today we're launching out of Space Launch Complex 40 at Cape Canaveral, which is one of SpaceX's 2 East Coast launch sites. On the pad, you can see here that 2-stage Falcon 9 vehicle, which stands 70 meters tall, and that's taller than a 20-story building. The first stage, which is the bottom 2/3 of the rocket, is our booster stage, and that, along with the 9 Merlin engines, is what does the bulk of the work to get Falcon 9 from the ground and up into the thinner parts of the Earth's atmosphere to the edge of space. And we're going to attempt to land this stage today on the drone ship after it separates from the upper stage. Now that upper stage, or stage 2 as we call it, that's right on top of stage 1 and has a single MVAC engine on it. That's Merlin vacuum engine. That's the engine that ignites after stage 1 separates and begins its journey back to Earth. The second stage is what's going to carry TESS from the edge of space and accelerated it to orbital speeds of just over 7.5 kilometers per second. Now TESS is currently sitting on the very top of that stack inside of our 17-foot diameter payload fairing. That's that nose cone structure you see on your screen up top. The fairing is what protects the spacecraft from aerothermal heating and loads as we launch it into space. Once we reach vacuum, we're going to separate the 2 halves of that nose cone of that fairing and have them come back to Earth because we don't need them anymore. Now the truss structure that you see on your screen there, that is referred to as our transporter erector. This is what we use not only to roll the rocket out of the hangar and to the pad and then to lift it up and support it in its vertical position, but is also what routes Falcon 9's fluids, power, and telemetry umbilicals from the ground systems all the way to the vehicle itself, and does so until Falcon 9 goes on internal power and launches and clears the pad. At that point, the vehicle's internal flight computer and automation and radio frequency communication is what's going to take over. Now, following successful deployment of the TESS spacecraft, this is going to be the 52nd Falcon 9 launch, the 24th Falcon 9 landing if we're successful today, and SpaceX's 8th launch this year. Operators began loading propellant on the Falcon 9 at T minus 70 minutes. And Falcon 9 is powered by bipropellant engines. That is, they consume a fuel, which is RP1, and an oxidizer, which is liquid oxygen. Fuel is about 90% or so loaded on the rocket in on stage 1, and 75% loaded on stage 2. Oh, I'm sorry, actually RP1, the fuel is fully loaded on stage 1 and 2. And it's LOX that's about 90% loaded on stage 1 and 75% loaded on stage 2. Now, liquid oxygen is that super chilled oxidizer that we use inside of our ox tank. And coming up next, what we're going to hear on the call out is engine chill. This is where we flow a small amount of that liquid oxygen through to the engines in order to cool them down to their operating temperature, so that when we start feeding them their full flow of liquid oxygen in flight, that LOX stays nice and cold and doesn't heat up and start to boil off and cause bubbles and other performance issues on the engines. Listening in on the weather nets, it's sounding like we are looking good for an on-time launch today. I'm not hearing about any issues with upper-level clouds. Our ground-level winds are looking within limits, as are those upper-level winds, and we're within our lightning rules. Spacecraft is currently healthy, it's on internal power, and the range is currently go for an on-time launch today. So today's mission is really, really cool. We are launching NASA's Transiting Exoplanet Survey Satellite, or TESS. This is a mission that's operated by MIT, managed by NASA's Goddard Space Flight Center, and is the second launch that SpaceX has conducted for NASA's Launch Services Program. And at just 365 kilograms and just under 5 feet tall, TESS may be small, but it is doing big things. This Planet Hunter is an orbital observatory that will discover thousands of planets by monitoring over 200,000 stars in nearby planet systems, or star systems. Its science instrument is comprised of 4 high-tech, wide field of view cameras designed and manufactured by MIT's Lincoln Laboratory. These cameras will allow TESS to detect exoplanets, which are planets that are outside of our solar system. It does this by looking for a phenomenon known as a transit. This is where a planet passes in front of its host star, causing a periodic dip in that star's brightness. This allows scientists to assess the size, mass, atmospheric composition, and structure of those planets. And this is particularly exciting to astrophysicists and astrobiologists because some of those planets may fall into what is referred to as the habitable zone. That means it might have the right conditions to sustain liquid water and potentially support life. Falcon 9 will be injecting TESS into an elliptical high Earth orbit that at its highest point reaches 273,000 kilometers. That's over 2/3 of the way to our moon. After TESS separates from Falcon 9 over the next 60 days, the spacecraft will use its onboard thrusters to perform a series of maneuvers, which includes a flyby of the moon in order to slingshot it into its final high Earth science orbit. This orbit is what's going to give TESS an unobstructed view of the night sky, allowing the spacecraft to observe and catalog thousands of exoplanets for future studies by the James Webb Space Telescope, the Hubble Space Telescope, and large ground-based observatories.
Internal sequences have started.
All right, we are about 4 minutes and 45 seconds away from liftoff. So let's check in on the rocket one more time before stepping into the terminal count. Fuel is fully loaded on both stages, and liquid oxygen is being topped off right now as we speak. The rocket is also now pressurizing itself with helium gas. We use that gas in order to maintain the structural strength of the rocket while on the ground and in flight. And very soon what you're going to see is those cradle arms that are holding the rocket, they're going to open up, and the transporter erector is going to lean back slightly. It's going to retract. You also might see some venting coming from the side of from the TE. That's totally normal. It's just liquid oxygen that's boiling off, heating up, and being released from the tanks. At T-minus 1 minute, the rocket's internal flight computers are going to take over, which you're here on the countdown net as Falcon 9 is in startup. The range is currently looking good for an on-time launch today. The payload is healthy on internal power and is go, and weather is go. We are looking awesome for a 6:51 p.m. T0. Now our launch window today is only 30 seconds long, but that's pretty much an instantaneous window. If for some reason we can't get off today, we'll come back again tomorrow at 7:09 p.m. Eastern time to give it another go. So with that, let's listen in to the last 3.5 minutes of terminal count.
Strong is at retract angle, 88.3 degrees.
I'll go bleed verification. Stage 1 lock cell complete. Stage 2 dump manifold secured. Stage 2, lock slow complete. Falcon 9 is on internal power. Vehicles in soft line.
Ground gas closeouts is starting.
AFTS is ready for launch.
Falcon 9's in startup.
Ground gas closeouts is complete.
Stage 2, pressing for flight.
LD, go for launch.
Stage 1 is at startup pressures.
T-minus 15 seconds.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, liftoff.
Ground operators proceed to section 575. Flight report to procedure 3170, post-launch flight operations.
Vehicle switching downrange.
Stage 1 propulsion is nominal.
As you just saw, Falcon 9 has successfully cleared the pad and is now on its ascent with the test spacecraft in its fairing. Now coming up in about 15 minutes, you're going to hear the call out that Falcon 9 will have hit max Q. That stands for maximum aerodynamic pressure. That is the point at which the rocket is seeing its highest stresses on its ascent.
Vehicle has passed maximum aerodynamic pressure.
You can tell by the cheers and what you heard on that call out, we have gotten through max Q. Coming up next, you're going to hear the call for MVAC
MVAC engine chill has begun.
And that was it. That is where we chill in that Merlin vacuum engine down to operating temperature. Now coming up here shortly, you're going to hear 3 big events happening in rapid succession. The first is MECO, that stands for main engine cutoff. That is where all 9 of the first stage engines are going to shut down. That's in preparation for the next step, which is stage sep, or stage separation. There's where stage 1 will separate from stage 2. Stage 1 will make its way back down to the drone ship. Stage 2 will continue on with Tess to its orbit. And then you're going to hear second engine start. That is the ignition of the second stage engine. Let's check it out here.
MECO.
Stage separation confirmed.
Stage 1 is out of its foot. MVAC ignition.
Right, and as you just saw, we had a successful stage separation and a successful ignition of that second stage engine.
Fairing separation
Now the
confirmed.
fairing should be deploying at any moment. There we go. And you can see that tiny but strong test spacecraft inside of that, or on top of stage 2. Now stage 1 is making its way back down to Earth. What we're going to see coming up pretty shortly is a boost back burn.
Grid fin deployed.
Grid fins have deployed.
Both stages following nominal trajectories.
Acquisition of signal, Bermuda.
Right now, stage 2 is going to continue to burn until T plus 8 minutes and 20 seconds, while stage 1 makes its way back down to Earth. Now, there are 2 more burns coming up for stage 1. The next one's going to be the entry burn. That's where we're going to reignite 3 of the stage 1 engines. And that burn is intended to slow down stage 1's descent as it makes its way through that thick upper atmosphere. We'll be seeing that at 6 minutes and 29 seconds or so in about 2 minutes. We're hearing that stage 2's burn is still performing nominally. Okay, stage 2 is going to continue to burn for about another 3 minutes and 1 minute until we see that re-entry burn. Now, after that re-entry burn, stage 1 is going to continue on making its way down to the drone ship, and coming up thereafter will be the landing burn. That'll be the 3rd of the 3 burns, and at that point we're going to reignite that center engine, E9, and that'll bring us down to 0 velocity, hopefully standing up tall on the drone ship. Continuing to hear that MVAC D is looking good. Turbopump performance is good. Everything is performing nominally on stage 2, which is great news.
Stage 2 continues to follow a nominal.
As you can see, that burn has begun, that entry burn. This burn is going to go for about another 10 seconds or so before it shuts down. And the entry burn is complete.
Stage 1 should better shut down.
Okay, as stage 2 continues to burn, we are getting Tess into a nice circular orbit where Tess will then, well, stage 2 with Tess on top will coast for about 35 minutes.
Stage 1 is transonic.
And as you heard, stage 1 is transonic. We're about 10 seconds away from that landing burn. Note that the drone ship is situated approximately 300 kilometers off the coast of Florida. And as you can see, that landing burn has started.
Stage 2 is in terminal guidance.
Let's see if we can catch it. screen. The first stage has successfully landed on Of Course I Still Love You. This marks the 24th successful landing of a Falcon 9 first stage. And meanwhile, we've reached SECO, which is second engine cutoff. Stage 2 has shut down its first burn. Now, stage 2 should be in a parking orbit of about 250 by 250 kilometers. Stage 2 is now going to coast for 35 minutes or so. So why don't you come back here at T plus 39 minutes, where we're going to bring you back to the webcast, where we're going to resume it, and we will be relighting the second stage engine for a second time in order to raise the apogee of our orbit to 273,000 kilometers. That gets us into Tess's highly elliptical orbit, where we will then deploy the spacecraft. So we're going to continue showing you some live views of space and of Tess and of stage 2. And we'll be back to commentate the webcast at T plus 42 minutes.
Lost the signal at Cape Canaveral as expected. expected. Acquisition of signal, Mauritius.
And back engine chill has started.
Welcome back, everybody. We are coming upon the end of our 35-minute coast, and the second engine is about to reignite. Just heard on the nets that MVAC chillin' has begun, and pretty soon the second stage will be reigniting to take Tess to its deployment orbit. In about 30 seconds, we're going to see that engine reignite. From there, the burn is going to last for about 1 minute before the engine shuts down again. And a few minutes after that, the test spacecraft will deploy. And as you just saw there, we have reignited the second stage. And this burn's going to last for about a minute. This is raising the apogee of our orbit so that we can drop Tess off at a place where it can then properly begin to perform its own orbit raising maneuvers to get it to that point where it can perform its lunar flyby. We are beginning to throttle everything down, hearing that everything is looking totally normal on this burn, which is really good news. And the engine has shut down.
And that cut off.
So for about 5 minutes, The stage is going to coast with Tess on top,
Orbital insertion.
at which point the payload is going to deploy. Now, the way that that works is there is what is referred to as a payload adapter that is sitting on the top of our second stage, and Tess is attached to that. It's attached via a clamp band, which is basically like a banded spring. We'll send a separation signal to Falcon 9, which will then open up that clamp band, and there will be 4 springs inside of that payload adapter, 4 compression springs that will give Tess a little gentle push to push it away from stage 2. And after a while, a few minutes after that, Tess is going to turn on its transmitters, on its receivers, deploy its solar arrays, and begin its mission. So let's watch these live views for the next 4 minutes or so, and we'll come back for a live view of payload deploy.
Also signal Mauritius as expected.
Back, everybody. We are now gearing up for spacecraft deploy. That'll happen in about a minute. This is where we're going to separate the Tess spacecraft from Falcon 9, and Tess is going to go on about its own journey, where it's going to be using its own onboard propulsion systems to raise its altitude and get it into its mission orbit. We'll be getting acquisition of signal as we pass over a ground station here shortly, and ideally we'll be able to see
Acquisition of
this
signal,
live
Western Australia.
on the screen. And there we go. In just under a minute here, we'll be seeing the spacecraft separate from Falcon 9. Look at that beautiful image of the Earth behind us there. It's one of the planets Tess is going to look at in its lifetime. And as you can see there, we have had successful separation of the Tess spacecraft. And it's going on its beautiful mission to look at thousands of planets outside of our solar system. And with that brings us to an end of our webcast, as Falcon 9's job is done for today. So this was a pretty successful mission, right? We had a successful Stage 1 ascent and landing. Stage 2 has properly deployed to Tess spacecraft into its intended orbit, and Tess is now on its way, and hopefully we'll hear soon about the health of the payload. I want to give a big thank you to the NASA Launch Services Program for their faith in us, to Goddard Space Flight Center, to MIT, and to the 45th Space Wing for their range support for today's mission. You can follow SpaceX on social media via our Twitter feed as well as our Instagram. You can also check us out on spacex.com. And if you want to learn more about the Tess mission, visit nasa.gov. Thank you all so much for joining today, and we'll catch you at the next launch.